Howdy folks. In continuation of our YouTube video, Preventing Oil System Failures in the Milwaukee-Eight engine, we have a little case today where we're looking at a short block here for a Milwaukee-Eight. And this particular package had a 124 sleeper kit in it that was doing well, as we can see here. We believe it has somewhere between 10 and 15,000 miles on it. And the reason why the engine's apart right now is this is going to be upgraded to a higher output package. And so we wanted to take this crankcase, knowing that it's been in service, and take a little look to reflect on what we have here from the previous video, where we were looking at why and how RTV silicone could get lodged in an oil feed jet that is the lubrication for each cylinder. And so because this is an engine that's in service, it hasn't been taken apart, this is a factory lower end that's intact, we wanted to take a closer look at it to see what the silicone looks like, the sealer. And as we come over here, we see on the exterior side, I can peel that back, you can see how there's quite a bit of sealant that's been squeezed out when the crankcases were put together. And we also see that it's heavily inside the crankcase on the cylinder spigot area. And we see it over here. There's definitely some there. And we see it on the back side. And over here we just took a look at our probe, and lo and behold, there's actually a piece that's loose. And if you go down into the inside, you can see a fair amount of RTV that's squeezed out between the two crankcase halves. And see, the concern here is that this stuff is when it's heavy like this, it can break off. There's a piece there that's it's just ready to break off. And once it breaks off and gets down into that churning system of the balancer and the flywheels churning around there, it's going to make its way through the oil system and through the oil pump, and then again it can come right back into here, and we could have partial blockage or 100% blockage, which in turn is going to create an engine failure, because you're not going to have enough oil to cool and protect the piston and the liner, and the game is over. By the time you realize what's happened, it's too late. So during your assembly process, your inspection and assembly process, you're going to want to look at this. Some shops are reporting to us this is their standard operating procedure now. They look at this, they'll take a scribe tool or something like that, get these loose pieces knocked off, and get them flushed out of the lower end to assure that this won't come back to as a problem on your build as you proceed on with your final assembly.
Okay, so we cut apart the filter that came off of this Milwaukee-Eight bottom end that had excessive RTV, and you can see there's two chunks of RTV down inside the filter. Then when we look at the actual filter material itself, we find a couple more. Here's a pretty large piece, and there's another piece over here that we have found. So here's another big chunk that has come out of the filter from where we had cut it. It's actually quite substantial. And there's probably more in here, given the way that this was cut apart. But the fact that we have found something shows that it is working its way through the engine. Now, why can this end up, or how does this end up back in your piston cooling jet? Well, it's pretty simple. Actually, all filters have a bypass valve on the top of it. And when you're at cold idle, there's actually a point when this bypass opens. So all oil going through the oil filter at certain viscosities will actually open up. So even when you think you have the best filter, it can still blow right past it at cold idle.
So that's our video for today. Thanks for watching.